Right. Hello, everybody. Welcome back to the stream. Hope you're having a wonderful evening so far. Today is Friday, the 21st. Oh, happy Friday. We made it to Friday. Short week for me, actually. My only day at work was yesterday, or today, sorry. Short week for me at work, but super happy to be Friday. It honestly feels like I got to go to work tomorrow, so it's kind of a strange feeling. But we are here back streaming, so we are good to go. Thank you guys so much for joining me this evening. Hello, Mahan and Tim. How's it going? Welcome. Welcome back, you two. You guys are always back here so quick. Thank you guys so much for joining me, my friends. How are we doing this evening? Hopefully, you guys are all good. Hopefully, nothing crazy's going on since yesterday. Day number, yesterday was day 0 of the stream streak restart. Today is now day 1. Day 1 since an absence. One day, yeah, right? So we are continuing on. Tyler, no way, not yet, not yet. I was thinking we try to cherry pick a couple easy ones to build some confidence. We'll move on to some harder ones. Need to get that confidence up. Wow, everybody's rolling in here. Thank you guys so much for joining me here. You guys are awesome. Ryan, welcome back. How's it going, man? Tyler, obviously, welcome back in. Wing Hong, hello. Awesome, you guys. Welcome back. David is me. Woo! Welcome back, man. Vacation was good. We're back in our element here today, feeling good, ready to stream. Did a long stream yesterday of almost like 5 hours. So it was good, catch up with everybody and get back into it. We are going to watch the back half of the Harvard CS50X 2025 Lecture 7 on SQL or SQL. Yesterday we learned a lot about this during the first half of the lecture, right? We took a lot of notes regarding the SQL, right? So we learned about flat file databases, right? A simple type of database that stores data on a single table, typically in a plain text or CSV format. Each line represents a record, and a field within each record are separated by a specific delimiter, like a comma or a tab, as in like CSV. Right, CSV, they mimic a 2D array by separating values columns with commas, right? We know that that's kind of self-explanatory. We learned about this get method, which will actually retrieve the actual value from just a given key in a dictionary. If not, a default will be provided. So we learned about that. We learned about relational databases. So we need to finish a couple of definitions here. So we learned about structured query language, where we have CRUD, right? We have create or insert, where we can create tables with this command, and we can insert into the said table, um, and with these values, right? Insert into favorites these columns with the values, these values, right? Null will be placed as the values for columns not during the insert into, not given during the insert into, right? And then we learn about various other functions and methods relating to this. So we have some key words here rather that we can specifically organize data or access specific data via column or whatever, or kind of similar to, honestly, if you've ever worked with like Excel or Sheets, how you would run commands within just the Excel prompt line for that specific cell. It's kind of similar to that, so it doesn't seem too bad so far. But how is everybody doing tonight? Me and Tyler are here for 4, so you guys are killing me. You guys want me to see me struggle. You guys are like, what are they called? I don't know. You guys enjoy watching pain. Come on, stop it. Yes, Zanah, we are growing right up. Thank you guys so much for all the support and love. We're coming up on 1.4 thousand subscribers. So still climbing up there, grinding away on the stream, and gathering a community together here of programmers of all different skill levels, just to hang out and enjoy some studying, and just learning together here. All right. Without further ado here, you guys, let's go ahead and get started back with watching the lecture here. I will do my best to respond to prompts in the chat. I'll type away back at you guys, and we'll pause every like 15 or 20 minutes when he allows for it, just through when he asks for questions, and then we'll catch back up on the chat. So let's go ahead and get started, you guys. Thanks so much for joining me here. we're going to continue on and finish this up. Let me know how the audio is.
All right, we are back, and we now dive into the Internet Movie Database, or IMDb for short, which again has a lot of real-world movie stars, TV shows, movies, writers, directors, and so much more. And all of that data, it turns out, is downloadable in TSV format, tab separated values. And so among the things we've done before class today is we actually wrote a program of our own. Turns out it was in Python, but it could have been in any language, to automate the process of importing those TSV files into our very own movies and TV shows databases. For today's, we're going to focus on TV shows in the world, with which many of you are likely familiar. So we thought we'd go about showing you how we might design a database for TV shows. So let me begin with just some quick and dirty spreadsheets, in fact. If I go back over to my browser here, I've got a Google spreadsheet open wherein I'm storing the title of one of my favorite TV shows, The Office, and then I have a lot of TV stars who featured in that show. Steve Carell, Rainn Wilson, and so forth.
Thumb up in the chat if you like The
But
Office.
even in the world of spreadsheets, I would argue that this way of associating TV stars with the TV shows they were in is maybe not the best design. Why? Well, here I have just 5 of the TV stars from The Office, but there were certainly many others in that ensemble show. But so where does this design end? Do I add another star column, another star column, another star column, and the like? But that doesn't seem like the best design, because then when I add a second TV show to this same design, then I'm going to have a different number of stars for that show and a different number of stars for the next show and so forth. So this doesn't feel like the best design to use columns to store each and every TV star in a TV show. Well, let me propose that we look at a second version of this that I whipped up in advance, whereby maybe we stick to just 2 columns. I like this better because from the get-go I've got 2 and only 2 columns, and this thing isn't going to grow wider and wider with more and more TV stars. But I also don't think I love this design. Why? Well, because in the first column, I've got the title of the show, The Office, but I've got it again and again and again and again, one such row for every TV star in the second column here. So this feels more compact, sure, but there's a lot of duplication now. I'm literally repeating The Office again and again and again. So the right way to do this, not necessarily in the world of spreadsheets, but as we'll soon see in the world of relational databases, is as follows. In fact, it's just convenient visually for us to use a spreadsheet just temporarily to mock up this idea. But I dare say the right way to solve this, as we'll soon see in relational databases, is not even with a single sheet, but rather to start using our database tables, or in this case, temporarily sheets, to represent real-world entities or relationships therein. In particular, notice at the bottom of my Google Sheet here, I have a Shows tab, a People tab, and a Stars tab. In other words, in the world of TV shows, there are, of course, the shows themselves. That's a real-world entity, each and every show. Okay. But there's also lots of people in that industry, the actors, the writers, the directors, and so forth. So people is another real-world entity. But then there are the people specifically who star in those shows. And that's more of a relationship. So we've got entity, entity, and relationship. So notice here in my Shows tab, I have the beginnings of a sheet for just all of the TV shows in the world. There we have in the second column The Office, which is the one we keep talking about. And just for the sake of discussion, let me propose that it will be advantageous to us and good design to assign every TV show in the world a unique ID. Doesn't really matter what it is, but some unique number that no other TV show is using is probably helpful. So for The Office, for instance, I'm going to arbitrarily, but deliberately, we'll soon see, use 386676 as its unique ID. Meanwhile, if I click on the People tab now, here are the real-world people. That is to say, people are an entity unto themselves. And here we have, again, Steve Carell, Rainn Wilson, and so forth, each of whom has their own unique ID, which is, again, an integer. And it could be the same numbers as before, but in the context of people, these IDs must be unique. In the context of shows, these IDs must be unique. So there isn't necessarily a relationship yet. But if I go to the third and final sheet here, the Stars sheet, notice somewhat cryptically, I have no TV shows, I have no people, but I do have the unique identifiers for both. And the way I propose to maintain relationships between shows and people is by somehow linking their unique identifiers together. So if I want to associate Steve Carell and Rainn Wilson and other people with The Office, I include their ID, and so forth. But in the left-hand column, I associate those person IDs, so to speak, with the corresponding show ID. Now, I do concede that there's still some duplication here. I keep seeing 386676. 386676, which is obviously the ID for The Office. So there's still some duplication here, but the duplication does not extend to these longer strings of text, The Office, but rather these smaller integers. And that I'm going to be OK with. In the world of relational databases, we shall see it's very common and generally good design to use simple integers, but unique, as your identifiers for data. It's OK if you have duplication, therefore, of those integers, because what? It's 32 bits, maybe 64 bits. It's not a variable number of characters, as would be the name of a TV show like The Office, or heck, a TV show with an even longer name. We can gain efficiency by just using simple integers. But unfortunately, this spreadsheet, I do concede, is no longer nearly as useful to look at as the previous versions, because if I want to see shows, I have to go here. If I want to see people, I have to go here. If I want to figure out who stars in what show, I have to go here. But these numbers mean nothing to me, the human. But that's why we're transitioning now away from these spreadsheets again to a proper relational database. Because with SQL, this programming language, we can somehow join these disparate data sets together and get back the answers to the questions we want to visualize exactly the data we want, but underneath the hood, so to speak, all of the good design will be intact using integers to relate one piece of data to another. So indeed, in the world of IMDb, we're about to see even more data than this. In fact, what we'll see now is this so-called schema. And recall from earlier that the schema for a database is the design of that database. And it turns out there's fairly standard ways of drawing databases and database tables therein and the relationships between those tables. But we'll focus step by step on subsets of this data here. But the picture you see on the screen here really represents a shows.db database containing lots of information on TV shows from IMDb that's apparently going to have 6 tables. And among those tables, at top left, are the people table. And then we have, at bottom left, the stars table. In the middle, we have the shows table. Below that, we have a writers table. And then above that, in top right, we have the genres table, which will give a genre to each of these shows, and the ratings for each of those shows. And indeed, that's among the reasons IMDb is popular, is that it offers up ratings or people's evaluations of these various films. But let's indeed focus on just a subset of this for a moment. Let's focus on the world of TV shows at left, and at right, the ratings thereof. Now, technically, these two tables could be combined into one, but insofar as ratings are such a prime feature of IMDb, and they themselves are sort of a real-world entity, the ratings for shows, IMDb chose to store ratings in a separate table, or technically TSV file, so we've opted to do the same for consistency with the original data set.
Okay, I get it.
But let me go ahead now and open up VS Code again, whereby I still have my files from earlier, but we're done with those, favorites.csv, favorites.py, and favorites.db. But during break, I also copied into my code space a big database called shows.db, which is like 50 megabytes of data from IMDb itself, as seen in top left of my Explorer. Let me go ahead and close the File Explorer, though, for now. Let me increase the size of my terminal window as before, and let's go ahead and open up this new shows.db file. I'm again going to use SQLite 3. Shows.db, enter, and rather than create this file, which I did the very first time with favorites.db, this one I showed you already exists, so I'm simply opening it by running SQLite and then the file name. Let's just go ahead and start wrapping our mind around some of this data. Let me go ahead and do something like select star from shows semicolon. Again, my sort of go-to default command just when I want to get a sense of what is it I have in front of me. Enter. And it's taking a while now. All of our favorites thus far kind of flew across the screen, but we are looking at decades worth of TV shows now flying across the screen here.
Wow.
So I would wager that we've got not even hundreds, but thousands, tens of thousands, hundreds of thousands of TV shows. This is a very large database. And so we're now going to really be applying the principles of good design to make sure that when we execute queries, when we design databases, we're indeed doing it well. Because you can imagine for real-world websites like IMDb, you can't really afford to make poor design decisions because real-world users are using that site. They want to get quick results. You want to minimize the number of servers you have, the amount of money you're spending. So good design decisions aren't going to just translate into good problem set scores now, but actual time and cost savings in the real world. Yeah. In fact, that was a lot of rows flying across the screen. Let me clear my terminal for a second, and let me just do a quick select count of star from shows, semicolon, and indeed we'll see there's 234,000 TV shows in the database as we have saved it here. If I want to see just the first 10 of those shows, there's other syntax I can write too. Let me go up in my history, and if I don't want to see 240,000 rows all at once, well, I can limit myself to the first show, or maybe more usefully, the first 10, just so it fits on the screen. And indeed, we have a bunch of shows from the 1970s, one from 1981, and if I limited it to even more rows, we'd see more and more films. But what is it I'm looking at? Well, it looks like in the shows table, I indeed have an ID for the show. I have a title for the show. I also seem to have the year in which the show debuted on TV for the first time. And as of now, the total number of episodes that are associated with that show. So it's a helpful way to just look at a subset of the data just to see what kinds of data is there, even though it's non-exhaustive. How about the ratings? Let me go ahead and do the same thing. Select star from ratings, limit 10. Whereby I just want to wrap my mind around this table as well. OK, I can infer here that in one column is the show ID, which I'm guessing corresponds to the ID in the shows table that we just looked at. There's a rating column, which seems to be out of 10, I'm guessing, from 0.0 to 10.0 for an average. And then the number of votes by real-world humans on the internet that contributed to that average rating. So just at a glance, I can kind of infer what this data set looks like in the absence of any additional detail.
6.8 on 35.
Now, what you'll see here implicitly is an example of what we would call a one-to-one relationship. It turns out that with relational databases, you can indeed have these relationships across tables, and they can be different types of relationships. One-to-one means that every show has one rating, according to the design of IMDb's database. And I can kind of infer that as follows. If I have in my shows table up here an ID column that I'm inferring, and I could confirm from IMDb's documentation, uniquely identifies each of these shows. When I then see in another table a column that by convention is called show ID, the implication is that that's not a unique identifier for this table's rows, but it's a reference to, if you will, another table's unique IDs. So this is just one convention, and there's many in the real world, but in the original table where the data is defined, like TV shows, the unique identifier is typically called ID. But when that same identifier is used elsewhere in another table for cross-referencing purposes, it is typically written as table name underscore ID, but you change the pluralization to be singular, so show ID means that it probably comes from a table called shows in the ID column. So I'm just inferring, but frankly, again, per the documentation, I bet I could confirm as much. And if indeed we do go back to the visualization of this database and take me away, you'll see that the arrows drawn between shows and ratings actually implies this kind of relationship, whereby every show has a one-to-one relationship with its one rating in the other table. Now, how can we go about wrapping our minds a little more formally about what's in this here database? Well, let me clear my screen, and let me use that schema command, but let me use it slightly differently. Previously, for my favorites.db, it just showed me the schema for the design of my favorites database. That was super simple because that was all automatically generated from that .import command. This database, again, I claim we created ourselves using IMDb's own data. So what we did in advance of today is this. If I want to look at the schema or the design specifically of my shows table, it looks like this. And we've tried to format this line by line to be a little more readable than the automatically generated one for favorites. So at some point, we, the staff, ran a command called create table, and we created a table called shows. Inside of parentheses, we then specified what are the columns for that table. The first one we decided to name ID, and we decreed that it's actually going to be an integer, a number from, say, 1 on up. The next column is going to be a title column.
Okay.
It's going to be text because, of course, The Office and other such TV shows have text as their name. And in particular, we want to make sure that no TV show's title is null. After all, if it's null, that means we don't have it. Why is it in our database? So that's just kind of a business decision. I do not want blank data, null data, in my database, because what would it even mean for a TV show to have no name? That's not really useful data at all. Then we have a year field, which, yes, is an integer, but it turns out for things like years, it turns out that it's SQLite. You can specify more generally that it's a numeric value. So it's like a number, but it's a special type of number, like a year. It's not just a boring old integer. Episodes, though, is just going to be an integer, because we just want to count 0, 1, 2 on up. There's nothing really special about that. And then the last thing here, after the final comma, is a little different, but we'll come back to this, whereby the primary key for this table is ID. And for now, that just means that the unique identifier for this here table is going to be the aforementioned ID column. We're just telling the database what to expect. Meanwhile, if I do .schema ratings, which is that second table, very similar in spirit, but notice this. I've created a table in advance called ratings. And inside those parentheses, there are these columns. A show ID column, which, like the ID column earlier, is indeed an integer, but be careful here, it is not null. It would also make no sense if we've got this orphaned rating that has no relationship to a show, so we do not want show ID to ever be null. That rating has, of course, a real number as its value. So a real is similar to a float in C or in Python, whereby it has a decimal point, and that's apt for something like an average. And it, too, is not just real, but also not null. And then the number of votes that contributed to that average is an integer, because there's some number of humans who voted. That, too, should not be null. But the interesting part here, and here is the relation in relational database, notice that this last line of code here specifies when creating the ratings table that there's a relationship between this table and another. Specifically, show ID in this table somehow references the ID column in the shows table. And you'll notice sort of some keywords here. Primary key is what I said defines the uniqueness of the column. Foreign key is what imposes the relationship between this table and that. So henceforth, what we mean by primary key is a unique identifier for a table's rows. It is guaranteed to be unique row by row by row. A foreign key, meanwhile, is just the appearance of a primary key in some other table for the purpose of relating that other table to the original table. So it's foreign in the sense that it's the same number, but it's in a foreign land. It's in a different table that's somehow referring back to the original table. So this is just jargon, but at the end of the day, what's kind of nice here, these are just numbers. And we've tossed on a bunch of terminology here and jargon, but really we're just talking about reusing numbers so that we know, just like my visualization with the Google spreadsheet earlier, that there's a connection somehow between these two. Now, what about all of these data types? Well, here's a quick summary. Within the world of SQLite, these are really the data types you have available to you. And it's not that many. There is our integers for simple numbers, counting up or down. There's numeric, which are numbers, but things like dates and years and time. So things that are composed of numbers, but are a little different semantically. There's real, which are floating point values with decimal points. There's text, which is just text. And then we haven't seen it yet, but there's blobs, which is wonderfully named. And it stands for binary large object. It's like when you want to just store raw zeros and ones for some reason in the database, so that's not an especially common case, at least for our purposes, vis-a-vis these others. But there's these other keywords we should keep in mind, some of which we've already seen, like null and not null, which allows you to specify when creating a table what kinds of values can or cannot be there. And this is how a relational database differs from something like a spreadsheet. Generally speaking, in a spreadsheet, there is nothing stopping you from typing or deleting any values whatsoever from any of the rows and columns. In fact, it's pretty easy for you or a colleague to break a spreadsheet in that way. But one of the features you get from a real-world database like SQLite is that the database software itself can prevent you or other people, colleagues, users, from removing or adding data to your database that should not be there. You can specify that this column, this cell in our database table cannot be null, or it can be null, and you can specify that it must be unique, or it doesn't have to be unique. The database gives you those features for you. And indeed, these things called primary and foreign keys are the key to, no pun intended, relating one table's data to another table's data. So let's go ahead and start playing around with some of this real world data here. Let me go back to VS Code and let's poke around. If I now do select star from ratings, let's go ahead and look at like some of the most popular TV shows over the years. Now, if I just hit semicolon and enter now, that's going to give me all the ratings, and that's not that useful. But let me do this. Let me add a where clause, which we saw earlier, and say where the rating is greater than or equal to maybe 6.0. So it's better than 5, so it's at least 6 or higher. I don't really want to see hundreds or thousands of results, but let me go ahead and just limit this to like the first 10. It's not necessarily the top 10, because I'm not ordering the data, but just for the sake of discussion, I want to see 10 shows that seem to be pretty good based on their rating. All right? Not that useful, because what the heck are these shows? These are all unique numbers. I don't see the office's number in here. But I do see 10 show IDs that I haven't yet seen. Well, this isn't all that useful yet, but let me whittle this list down. Instead of selecting everything, let me re-execute that same query, but select just the show ID from ratings. Enter. So same kind of query, but a subset of the answer that I get back. I just have now a temporary table containing all of those show IDs. Well, why is this useful? Well, what I don't want to do is this. If I want to know what 10 TV shows should I start watching, this would be incredibly tedious. Select star from shows where the show's ID equals, and I'll copy paste this, 62614 semicolon. Enter. Okay, so that's the first TV show that debuted in 1981 that has a pretty good rating of 6.0 or higher. What's the next one? Well, let me start with that same query, but go back up here and copy the second ID, semicolon.
Come on,
all right, Catweasel. So from 1970, that seems to be pretty popular. Let me do it again. Let me delete that ID, grab a third ID here, copy paste it, enter. UFO from 1970. I mean, this is going to take me forever just to come up with my list of 10 TV shows that I should watch based on their rating. So there must be a better way. Copy paste is rarely, if ever, the solution to our problems in CS50, let alone programming more generally. Can I automate this process somehow, but in a way that shows me useful information? Because I, as the user, I really don't care about the primary keys, the foreign keys, any of those integers. Who cares? They exist solely for the purpose of uniquely identifying data in a database, but I am a human, and I prefer to think about TV shows by way of their titles. So how can I do this? Well, let me go back to that earlier query whereby I got all of the show IDs that are rated at least 6.0 or higher. Done. And now let me use this as kind of a building block to answer another question as follows. Let me do this. Select star from shows where the ID of the shows is in this earlier query. So here I'm going to copy paste, but just to save myself some keystrokes and make clear that I'm indeed using the same query as earlier, I'm going to copy everything from earlier, paste it here without the semicolon, and I'm going to move the limit 10 to the outside because what I care about is limiting the number of TV shows, not the show IDs per se. So it's almost the same, but just like in math class, because of the parentheses, this is going to be executed first by the database. That's going to give me back a list of IDs where the ratings are greater than or equal to 6.0. And then I'm going to use that list of IDs to ask the database a second question, the outermost question here. Give me everything you know about the shows whose ID is in that list of results. So I'm using one query inside of another. This is known as a nested query. And we do this all the time in C and Python. When you pass the output of one function into the input of another, that's all we are doing here. So when I now hit enter, what I should see is, thank you, actually 10 shows titles, not to mention their IDs and their year and their episodes. And indeed, notice the title, notice the IDs it left. Those are the IDs that we selected earlier, but thankfully I can see the titles now as well. And if I don't care to see any of that other information like year and episodes, that's fine. Let me just hit up again. And instead of selecting star, let me just select what I care about. All I care about is the top 10 TV shows that I should watch here. And now I have just the titles as well. So again, even though the queries are getting a little longer, and I could be a little more tidy, and I could move things to the next line and so forth, and I'll do that as an example, but it's just composing ideas from earlier into larger and larger queries by solving smaller problems first. And let me do this now. Let me actually type this out a little more clearly without wrapping. If in SQLite, whoops, let me do this. Let me go ahead and make this multiple lines. So if I were to start this query as follows. Select title from shows where ID in, but I know what I'm going to type is actually going to wrap onto multiple lines. That's OK. I can hit enter here. Notice my prompt changes to an ellipsis, dot, 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 and then the greater than sign. This is SQLite waiting for more of my query. So I'm going to go ahead and copy paste it from earlier. And then I still haven't hit semicolon. I'm hitting enter just to put it onto another line. But now I want to limit it to 10. And now semicolon. So I mention this because it's actually very easy to accidentally get into a weird place with SQLite, because if you have an open parenthesis or an open quotation mark, you might get the dot, dot, dot prompt, which just means you haven't finished your thought, at least as far as SQLite is concerned. So you can finish your thought with the semicolon, the parenthesis, the quote mark, hit enter, and now you have a 3-line command, which might just be a little more readable for you, but still executable. Worst case, if you get into a weird place, Control-C is your friend to interrupt the process somehow, to actually quit out of that query itself. All right, but there's a way now to do this differently. And I used this terminology earlier. Wouldn't it be nice if, even though we have a shows table and a ratings table and all these other tables, could we somehow join them back together when we want to see more data at once? And indeed, if we consider in SQL one other keyword, we can do exactly that. An operative word in SQL is that of literally joining 2 or more tables together. So what do I mean by this? Well, let's do this visually first. So here we have a visualization of a TV show at left and the rating thereof at right. And for today's purposes, I don't really care what the actual rating is or the votes were or so forth. So I've showed just a subset of the data herein. But these are 2 separate tables, shows at left and ratings at right. But notice, even though this is a tiny example, notice that they do have a column in common.
Yeah, they have
Notice
the show
that the ID
column.
value at left is the same as the show ID at right. Wouldn't it be nice if I could kind of take these tables then and kind of line up those identical values and concatenate them together by kind of joining them where those IDs are the same? And in fact, just for the sake of visualization, let me propose to do this. All I did was flip the title and ID column, not because this is technically useful, but visually it puts the 2 IDs up against each other. In fact, let me squeeze the tables closer together, noting that 386676 is indeed the unique identifier, and it's the same in both the shows table and the ratings table. So sure, let's kind of shift things over. And heck, I don't really need both of these values here at the same time, so I bet I could somehow literally join these 2 columns together in code. In fact, let me go back to VS Code, and let me introduce one other technique here. Select star from shows, join ratings. How do I want to join those 2 tables, left and right? Well, please join them on the shows table's ID column equaling the ratings table's show ID column. And, just for good measure, where the rating is greater than or equal to 6.0 and limit 10. So the last part there is not that useful. It's just borrowing some of the ideas from earlier. What is useful here is I'm not just selecting from one table now. I'm selecting from 2 tables being joined together. But I have to tell the database, how do you want to join those together? Like, how should those 2 tables be lined up? Well, I want the show ID column in one to line up with the I want the ID column in one to line up with the show ID column in the other. So you have full control over what values are being lined up. And if I hit enter, I will see everything together here. The ID column, the title column, the year of the episodes, and also the duplicate show ID column, rating columns, and vote columns, which is pretty much what we just saw. But my own visualization, I was keeping it simple, dot, dot, dot. I don't care about most of those columns. But this is what we have done. With this join keyword, we have created in memory a temporary table that has all of that data I care about, and in fact, a bit more. Now, at the end of the day, what I really only care about, if I go back to my visualization here, is I really only care about getting access to, say, the title and the rating itself. So if I want to whittle this list down even further, that's actually not that hard. Let me go back to VS Code. And as always, instead of just selecting star, let's select what I actually care about, like title, comma, rating. And if that's all you want, so long as it's clear to the database that, OK, titles from over here and ratings from over here, so long as the column names are not duplicative, I can just refer to them by their short names, enter. Now I get back 10 TV shows that I do want to watch, because all of these have ratings, as you can see with your eyes, that are greater than or equal to 6.0, and there are the titles thereof. So let's return now to the schema for the entire database, focusing not just on the shows table and the ratings table, but a few others as well. In particular, why don't we focus this time on the genres table, which describes whether a show is a comedy or a drama or something else along those lines. So let me go back to VS Code here, and let me go ahead and wrap my mind around this new table. So select star from genres, and then let's just limit 10. I don't really care about everything that's in this table, just want to get a quick sense of it. Okay, it's actually a pretty simple table, per the diagram from a moment ago, whereby the genres table has two columns, a show ID and a genre. And the show ID presumably refers to the ID column in the shows table, and genre appears to be a text field that describes the genre for that particular TV show. What's worth noting about the genres table is that this is not really practicing what we preached earlier, because indeed, I see comedy, comedy, comedy. I see it 3 times. I see sci-fi twice. So there is redundancy in this table, so feels like a missed opportunity to fully normalize these tables by removing those duplicates and having a whole separate table, much like we have a whole separate table for shows and for people themselves, but more on that perhaps another time. For now, let's go ahead and just focus on one of these TV shows that we saw earlier, that of Catweasel, one of those earlier UK shows. Let me go ahead and do select star from shows. Let's do select star from shows, where the ID of the show is this one here. Notice that what's curious about this show here, 63881, is that it's a comedy, an adventure, a comedy, and a family show all together. Now, I happen to know what this one is, but as before, let me go ahead and select it by its ID, where ID equals 63881, semicolon, and indeed, there's the Catweasel show that I've promised us. So it seems that Catweasel, per the genres table, actually has many genres associated with it. And this is worth noting because indeed, besides one-to-one relationships across tables, you can also have one-to-many relationships, whereby in this case, one show can have many genres associated with it. So to see this, let me go back to VS Code here. Let me clear my screen and do .schema for genres just to make sense of what's in there. And as expected, show ID is an integer that can't be null, that is apparently indeed a foreign key that references shows table's ID column. So quite like the ratings table, but the genre in here is indeed a textual value for which there might be duplicates, but it can never be null. All right, let's go ahead now and see if we can't select programmatically the genres for this TV show called Catweasel. Let me go ahead and first select the genre from the genres table where the show ID equals that same value. Okay, there's that list of 3 values that I inferred by just looking at the top 10 list earlier. But indeed, this show, 63881, aka Catweasel, has 3 genres: adventure, comedy, and family. So how can I go about selecting now the genres, plural, for this show? Well, frankly, I and no one in the world should really have to know what the unique identifier is for Catweasel. After all, if you were to go to imdb.com, it would be a bit crazy to have to type in the numeric identifier for a TV show just to search for it. So let's make this more like a keyword search. Let me instead say, select the ID from the shows table where the title of the show equals, quote unquote, Catweasel. In other words, I know from earlier, using select alone, I can get that unique ID of Catweasel. And I know from earlier that I can compose more sophisticated queries by nesting one select inside of another. So let me do this. I'm going to copy this just so I don't have to type it all out again. And let me go ahead now and select the genre column from the genres table where the show ID in question happens to equal the results of this query. And now notice a subtlety. Previously, when I nested a query, I actually used the preposition in because I was getting back a whole bunch of show IDs, and I wanted to get back the title of any show whose ID was in that list of IDs. In this case, Catweasel, by definition, only has one unique identifier, 63881. So instead of saying in, I'm more precisely saying equals. I want to select the genre for the show that literally equals this value. And SQL will accommodate that. So you use in when you want to search across multiple values, and you use equals when you know there's just to be one. If I hit enter, there we have it. I now have a query that, much like my first query, searches for all of the genres for the show, but it doesn't arcanely search by a show ID. It instead searches by the name of the show itself, which I'd argue is much more useful. Now we can visualize what might have just happened. Here are simplified versions of these two tables. We have the shows table at left and the genres table at right. And just for the sake of discussion, let me flip around the two columns just so we can see that these two things do line up, even though this is not a technical thing. Let me kind of highlight the fact that 63881 indeed appears everywhere among these IDs. So let's kind of nudge things closer together. And let's go ahead now and ideally line up all of these common values. But notice here that it's not a one-to-one. This is kind of a one-to-3 relationship, more generally known as a one-to-many. So really, when we line these columns up, what's actually happening, when you line these tables up, what's really happening is something like this. Select star from shows. Let's join them together on the genres with the genres table on shows.id equaling genres show ID, where ID equals 63881. So what have I just done here? Well, if my goal is to sort of join this stuff together, these tables together, as we did earlier, not using ratings but genres, but we want to accommodate for a one-to-many relationship, the query is essentially the same. Select everything from the shows table by joining it with the genres table. How to join it? We'll join it on the shows.id column and the genres.showID column. So that's what I mean by kind of lining them up just right so that those numbers overlap. But for the sake of discussion, I only care about one TV show for today. I could do this for all of them, but let's focus on just one. And when I hit enter now, notice what happens is I get, per the star operator, all of the columns from both of the tables, including ID, title, year, and episodes, but also show ID and genre. Now, the database itself, it's not bothering to flip things around and show me side by side like I did with my slides, but the idea is exactly the same. When I try to join these two tables in this way, what's effectively happening is the database is noticing, OK, I've got a value at left, 63881, and I got the same value at right again and again and again. So effectively, what's happening is the left-hand table's rows are duplicated verbatim, just so that when we get back a table, it has the same dimensions, rows and columns. Height and width sort of work out to the same. That does mean there's a lot more duplicative data that's coming back. But if you want to be able to see everything about Catweasel for each and every of its genres, this, in this case, is what the join query would be doing. We get back, yes, duplicate data, but it's fundamentally joining things in precisely the same way. Now, at the end of the day, I probably only care about, really, the title and the genre, so I can tighten this up. If I go back to VS Code here, and I select only title, comma, genre from shows joined with genres on shows.id equals genres.showID, where the ID is 63881. I'm just going to give back a much smaller table, exactly like the one I depicted a moment ago. And heck, if that's even too much, like I don't need to know the name of the show if I'm already searching for it. Well, let me hit up. Let me go to the beginning of my query, and let's just get rid of title and genre and just select the genre. And now I have a list in this temporary table of all of the genres for this particular show. If we bounce back, meanwhile, to the chart itself,
self-explanatory,
to the schema itself, there's even more tables than these. And in fact, we won't spend time going through each and every one of them, but I think it's probably worth showing one of them that really represents a third and final type of relationship that you might have in this or any database of your own as well, a many-to-many relationship. And indeed, that's the right semantics for something like TV shows and TV stars, because presumably one show has many TV stars, and one TV star is presumably, if they're successful, going to be in many TV shows. And so you sometimes want to have not a one-to-one, not a one-to-many, but a many-to-many relationship. And to do that, it does not suffice to have just two tables, like shows and ratings or shows and genres. You might need a third table. And this is where we began after the break by visualizing things in that spreadsheet temporarily when we have a shows, we have a people table, and maybe we have a stars table that somehow relates the first to the second. So how can we go about building that? Well, let me propose that we explore the data set as follows. Let me go back to VS Code, and let's just start to poke around with The Office again, one of my own favorite shows. And let's do select star from shows where the title of the show equals, quote unquote, The Office. Let's just see what we know about the TV show The Office. Now, as some of you might know, The Office in the US, with which I'm very familiar, is not the only version of The Office. In fact, the origin for it was actually a UK version several years prior. But I think the one that I'm most familiar with in the US is probably this one that started in 2005, if only because it had 188 episodes, because it ran for like 9 years, 9 seasons. So that's probably the one I'm thinking about, with Steve Carell, Rainn Wilson, and others. So if I want to narrow my search results to that, let me start with the same query, but say where the title is The Office and the year equals 2005, because I, for today's purposes, just want to focus on one of these here offices.
All right.
Now, suppose I wanted to ask a question like, who starred in The Office? Now, that question is very reasonable. And honestly, if you go to imdb.com and search for The Office, you'd probably expect to see a list of all of the TV stars in that show, the cast members.
So you say
but
select.
this data seems to be split across a shows table, a people table, and a stars table. So how do I get back a simple, common question, given what I'm proposing is very good database design? Well, let me propose that we take baby steps here, or small bites out of this problem, as always. Let's first select, how about the ID only from the shows table, where the title of the show is The Office, and the year of that show is 2005. I don't care about all of the columns. I only care about the ID. And I could make mental note of 386676 and then copy paste that. But again, that's not the right way to do things. I should not be hard coding the IDs literally when the user is going to care about the titles, not these IDs. But suppose I want to now get everything I know about that show as it relates to people. Well, let me go back to the schema for these three tables. Notice that we have the shows table here, which has an ID, a title, a year, and number of episodes. The people table has an ID, a name of a person, and their birth year. But this stars table is what we might call a join table, whereby its purpose in life is to implement this relationship between one and the other. And that table clearly has a show ID and a person ID. And this is where I'm now thinking. In my current query, I am getting the show ID that I care about. What I really want to know is who starred in this show, so I need a bunch of person IDs. Well, this is the table, the stars table, that associates show ID with person ID. So maybe I can kind of bootstrap things and use this one show ID that I just found all of the corresponding person IDs, and see where that gets us. So let me go back to VS Code, and let me do this. Select all of the person IDs from the stars table, where the show ID itself from that table is equal to, and now I need this query from earlier. So let me go ahead and do this maybe on a second line. Select ID from shows where title equals The Office and year equals 2005, close parenthesis, semicolon. In other words, I've got a nested query again, per my parentheses. I want the unique ID for The Office. Then I want to use that show ID to find all of the related person IDs. Enter. And I get back a whole bunch of person IDs. But who are these people? One of them is probably Steve Carell, one's probably Rainn Wilson, and so forth. But this is not useful information. So let's take this home one step further. Let's select the name from the people table, where the ID of that person is in the following query. Well, how do I get back all of those people IDs? Well, person IDs. Let me go ahead and do select person ID from stars, where the show ID equals, and now let me do another nested query. Select ID from shows where title equals, as before, The Office, and year equals 2005, close parenthesis, semicolon. So this must feel like a lot if you're seeing SQL for the first time, but realize that I'm just taking a third and final baby step. The first query I ever executed during this process was the last one on the screen here. Give me the ID of The Office that I know and love from 2005. The second line of code on the screen is the second command that I wrote before, whereby I want to select all of the person IDs from the stars table that are associated with that show ID. But that just gave me a list of person IDs, none of which I recognized visually. So the third and final step, which on the screen is the very top line here, select the name from the people table where the ID of that person is in that list of person IDs that I didn't recognize earlier. So if I didn't make any typos and I hit enter, I should see, thankfully, Creed Bratton, Steve Carell, Jenna Fisher, Kate Flannery, and so forth some of the top stars from that there version of The Office.
Nice.
So a big query to execute, but composed of smaller and hopefully seemingly simpler queries as well. All right, let's try one other query, not just searching for all of the stars of the TV show The Office. Let's just search now, conversely, for all of the TV shows that Steve Carell was actually in. So one way I could do this is very similar in spirit. Let me go ahead and select the title from the shows table where the ID of the show is in the following list. Select the show ID from the stars table where the person ID equals, and now I need Steve Carell's own ID. So much like I search for The Office's ID, let me search for Steve Carell's ID as follows. Select ID from the people table where the name of the person is, quote unquote, Steve Carell. Close parenthesis, semicolon. So same idea, but I'm sort of searching the tables in the opposite order to get back all of Steve Carell's shows instead of all of The Office's TV stars. Let me hit enter, and I get back all of the shows according to IMDb that Steve Carell has been in. But turns out there's another way to do these kinds of queries when you do have 1, 2, 3 tables involved. You don't have to rely on subqueries alone. If you prefer the idea of kind of joining the tables, not just 2 but 3 of them, you can do that as well. Let me do it as follows. Select title from shows joined with the stars table on shows.id equaling stars.showid, joined once more, so we're sort of combining all 3 tables at once in your mind's eye, the people table on stars.personid equals people.id, where name equals Steve Carell. Now, this is a different approach where I'm explicitly joining 1, 2, and 3 tables based on those common primary and foreign keys, but it's using the join syntax this time to get back all of Steve Carell's TV shows.
Nice.
And that was actually a little slower because it turns out there's some final opportunities we're about to dive into to optimize this database for faster queries. But let me show you one last way too. If that felt a little verbose, we can also search for all of Steve Carell's shows as follows. Select title from shows, stars, and people. In other words, you can tighten up a join query and specify all at once the 3 tables, in this case, that I want to select things from. And I don't even need to explicitly use the join keyword. I can do it implicitly by saying where shows.id equals stars.showid and people ID equals stars.person ID and name equals Steve Carell. In other words, this is just a third way to express the exact same idea. Give me all of the titles from all of the shows that Steve Carell has been in, joining them really implicitly by specifying which of the columns in one table must equal the columns in other tables. Enter. And I, again, with some suspense, get back now the same list of shows. Before we move on, let me summarize here that we have not only the tables we've looked at, but even one other as well, namely the writers table. And if we're curious as to what that is, we can actually poke around too. If I go back to my SQLite terminal and I do .schema writers, you'll actually see that the writers table is quite similar to the stars table. Because recall that the stars table associated people with shows, so does the writers table associate people with shows as well. But as per this one, we have a show ID and person ID, but the table name itself, writers, connotes that the relationship therein is indeed that of writers. As an aside, there's probably a better way to implement even that idea, because what about directors and producers and other people on a set? Well, more on perhaps that design opportunity another time. For now, I think it's timely where we try to chip away at the time of these queries and perhaps others.
All right, we'll put a pause right there while we answer some chats here. Sorry, guys, he's like just kept on going. What happened to his usual ask for questions? He's just yapping away over here, going on for like 40 minutes so far almost. Jeez. All right, we finally got to that end of that break there where we watched like 30 minutes of content. All right, straight without no break. for questions, but let's go ahead and catch back up on the chats here. Thank you guys so much for being here. For those that are new, my name is Michael. Appreciate you guys being here. I'm 26 years old. I graduated college back in 2021 with a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company where I make biological controls that are used in patient diagnostics and clinical research. I make, large baths of serum from blood, urine, plasma, all these kinds of biological fluids that are used in testing and research and things along those lines. Um, I have been teaching myself programming for the past 6 months, a little over 6 months now. I started, before the summer of 2024. I started with Harvard CS50P, where I then completed that course, learning all I could about Python and continuing on my Python journey with Python Crash Course, the book you see behind me here. I'm currently going back through on my channel and uploading the solutions to the try it yourself problems in the book that I've already completed, because we read that book and did all the problems live on the channel like we normally do. You can get access to all of my resources for the books, the notes you see on my screens, weekly updates for the courses in my Discord linked below, completely for free, all in there, kind of like a roadmap for my learning. All right. Let's go ahead and catch up on some chats here. Just a suggestion from Magnet. Have you thought about streaming on both Twitch and YouTube? I feel like you'd get more people to watch you on there as well. Honestly, people have asked me about that. I just haven't put in the effort to learn how. I know that I think there's some software that will allow you to multi-stream, but a lot of it has an additional charge to it, and currently the stream doesn't make any money or nothing, so I'm not really inclined to you know uh, pay for an additional service. Maybe if the stream gets to a point where it can be self-sufficient and keeping that service up, then yeah, I will definitely consider that for sure. But I have considered it, and I thought about it. Maybe we can try it out one day. We can stream one day a week on Twitch or something just to try it out. But if you guys have any suggestions for resources regarding multi-stream on Twitch or YouTube, let me know. I'm all ears. Caesar M coming in with some trolling here. um, of course, people fall under the illusion that A is going to replace all coders. That's not really about writing code. It's all about the problem solving that comes with the field. Actually, you understand the features probably not. You'll have to ask AI most models hallucinate when it comes to code generations for large scale projects. Magnet's going off over here. Hey, ESCM9SB, how's it going? Welcome back in. Hey. Yeah, so I can see how this can be useful for that whole joining of those tables really seemed useful. I've had a lot of cases in my work where I first had to sort columns and then combine the tables that way. So being able to do this would be really useful. Now, my question is can you intertwine this, you guys, for any of you guys that know this more than I do currently, can you intertwine this with Python in a way? So can I set up a database, have a database file be within my current directory in Python, and can I somehow bake into my Python code, importing SQLite or something, bake into there with some functions, these query calls to basically handle the querying or searching for items within our small business manager, right? So if you remember this project we're working on, we currently wrote functions for accessing and pretty much doing these queries within this database that we have set up. What if we actually, just created, individual databases for items, expenses, and JSON? Can we bake into our program here SQL query, prompts to then pull back and give back visually those return values that we've been manually having to create via print and loops and whatnot? Is that a viable option here? Everybody's saying yes. Here we go. Here we're learning it. Okay, this is getting exciting because now now we right now we don't have to do this all manually. We can instead, like what we're doing for like the view or whatnot. I wonder though, like, can we have the user specify, and can we like pretty much, can we have the, can we pull up like our prompts and say, okay, we want to filter by this, this, and this, and then can we pretty much format those into like strings, essentially, like, kind of like F strings into creating the SQL prompt? Only functions. Yeah, this is our program we got going on here, Tim. It's it's quite the beast that's been building slowly and slowly. I've you know we've gotten to a point where we're here, keep going here. All right. Let's go ahead and continue on with the lecture here. We have about 30 more minutes of the lecture. Actually, 30 more minutes almost exactly. Let me go ahead and grab a refill on my lemonade. Be right back. Kind of like that guy that has that. It's not bad enough to that point. It's somewhat organized, but I kind of like that guy that has that messy office with my project here with all of my functions. And then I'm like, and then if someone comes in, I'm like, don't touch anything. Like, I know where everything's at. Right, I know where everything's at. I just don't touch anything, and it'll all still be fine. That's how my dad was with his office growing up. Okay, let's go ahead and continue on with the lecture here. Uh, Tim says, great lecture so far. Awesome, Tim. Glad you're liking it. Zana says, nice. Right. Ryan, it's clicking. Awesome. Import SQLite 3. Okay, SQLite 3. Read the SQLite 3 docs. Okay. I had a guy send me a program, 3,000 lines with no comments, and I had to grill around. I understand. Yes, use triple quotes, strings goes here. Con equals SQLite connect your database. All right, let's keep going.
It turns out, besides just deciding when making your own relational database, whether it's with an automated .import command or manually, as we, the staff, did in advance for the IMDb data that we downloaded in files from the internet, we can structure our data in the computer's memory in a way that draws inspiration from week 5 of CS50 and week 3 of CS50, wherein we focused on data structures and algorithms, respectively. In the world of databases, you, the database designer, can choose in advance to create indexes, so to speak, on your own databases so that you can speed up certain queries. In fact, let me go ahead and show you in my VS Code environment with this same database how long it takes to execute a representative command. I'm going to go ahead and do timer on, which is a SQL-like command that's just going to count how many seconds or milliseconds it takes to run each and every one of my commands, just so I can see it without having to like look at my watch and time it manually. I'm going to now do something simple, like select star from shows where the title of the show equals, quote unquote, The Office. So I'm just curious to know how many seconds or milliseconds does this here command take. Okay. Enter. And it's pretty fast. In real time, it took definitely less than 1 second. In real time, it took 0.043 seconds. So that's actually pretty darn fast. But I bet I can speed it up even faster. Let me propose to do this. Let me build my own index inside of the database's memory using syntax like this. Create index, and then the name of the index, on the name of a table, these columns specifically. In other words, if I'm the designer of this database and I know that my users are going to be searching on the names, the titles of TV shows quite a bit, I can in advance tell the database to build a fancy tree-like structure in its memory or RAM so as to speed up searches for values therein. Okay. So how do I do this? Well, let me go back to VS Code and let me simply do create index. I can call it anything I want, but I'll just be clear with title underscore index so I know what I'm indexing. What table do I want to create this index on? Well, the shows table, specifically the title column therein. So here I have specified create an index, so a fancy tree-like structure in memory on the shows table's title column. Enter. So that itself took a decent amount of time, almost half a second, but that's a command I'm only going to run once. So it's an upfront cost, but hereafter I can amortize that cost over many more selects. Let me go back up into my history. This was the exact same query we executed a moment ago, which previously took 0.043 seconds. But this time, after creating the index, 0.001 seconds. And you might have thought earlier 0.43 was already pretty darn fast. I mean, 0.001 is an order of magnitude faster. What's the implication of this? Well, one, the human users of your website or application are going to get answers much more quickly. And maybe more importantly, in the real world, if I can handle like 40, if this query is like 1/40th the speed of the previous query, I can buy 40 times fewer servers to handle my users, because presumably a database server in the real world can only handle so many users at once. So if you speed up your query by a factor of 40, you can get away with that many fewer servers and that much less money as a result. So building this index in memory can be super efficient with the result in time. Now, what's the trade-off? Well, as in every discussion of efficiency thus far in design, there's going to be a trade-off. And when you build one of these trees in memory, typically known as a B tree, which is not a binary tree, it's literally a B tree, it's essentially a tree that's very short, or as short as possible. So it's not a binary tree in that each node has only 2 children. It might have 3 or more children as well. And the idea of having lots of children in this tree is that it kind of pulls the height of the tree up. So it might be very wide, but it's very short. So the amount of time it takes to get from the root node at the top to any leaf node at the bottom tends to be fairly minimalist. And you don't have to do any of this. There's no pointers. There's no C code. You, the developer, don't have to do any of this. When you create an index, what's happening underneath the hood is that kind of structure is being created for you instead. And we can really see this maybe with one of our same queries from earlier. Let me go ahead and propose that in VS Code, I bring back one of our slower queries from before. Even if you're not 100% comfortable with the syntax, just take on faith that it's the same fairly slow query I executed a bit ago. Select the title from the shows table, the stars table, and the people table, where the shows table's ID equals stars.showID, and people ID equals stars.person ID, and the name equals Steve Carell. I'm going to go ahead and hit enter, and because I've turned the timer on, we will now know mathematically how long this earlier query takes. Thinking, thinking, thinking. All right, and here we have 3.483 seconds. Like, that's annoyingly long, if you will. Like, that's going to be an annoying website waiting and waiting for the response to come back. And it's certainly going to cost other people time, because if I've got multiple users on the website, they too might be wanting to execute queries as well. Just to show how impactful these indexes can be, let me go ahead and revisit a query from earlier and show that we can speed up even our more sophisticated queries as well. Recall that when we were searching for all of Steve Carell's shows earlier, we did this. Select title from shows where the ID of the show is in the following subquery. Select show ID from the stars table where the person ID equals this subquery. Select ID from people where name equals Steve Carell. Close parenthesis, semicolon. I have my timer on now, though, so we'll see how long this one actually takes. Enter. And it's not too slow, but 0.215 seconds in real time. OK, can we do better? Well, notice in this query, we searched on a couple of columns. One, I searched for Steve Carell on the name column in the people table. And I also searched for the person ID column in the stars table. In other words, when I was asking SQL to filter my results by those two where clauses, person ID and name, it was probably doing a lot of work. And you can think back now to week 3 of CS50 and even week 0 of CS50 when we first implemented linear search, searching the phone book page at a time or searching the lockers one at a time. Linear search was slow. But these SQL tables are really just really tall lists of values. So if you want to search for a person ID or you want to search for a name, if you do not have a fancy data structure in memory already, like one of these so-called B trees that an index gives you, what is the database going to do? It's going to literally search over every person ID and every name looking for the values you care about. So can we help the database out? If I know I am frequently going to search on person IDs and names, let's create 2 indexes. So let me go back to my SQLite prompt and create one index called, say, name index on the people tables name column, because I want to search for names like Steve Carell. Semicolon, enter. It's thinking. That took over a second, but it's a one-time operation. Let's create one more index called, say, person index on the stars tables person ID. That too is going to take a moment, 2 seconds, but it's a one-time operation. Now, let's rerun my earlier query, remembering that previously it took 0.215 seconds. And that earlier query was, as before, select title from shows, where the ID of the show is in the following subquery. Select show ID from stars, where person ID equals the following subquery. Select ID from people, where name equals quote-unquote Steve Carell. Close quote, close parenthesis, semicolon.
Really fast.
Previously, again, this query took 0.215 seconds, but gave me all the results I cared about. Now when I hit enter, it's instant 0.001 seconds. So hundreds of times faster than the previous query just by building up these indexes in memory. So at the end of the day, what's helpful about these indexes is the massive improvement potentially in speed. But if we looked at how much space this database is taking up on the system, it's probably going to be more space because we have to store these B trees somewhere in memory or on the server's hard drive. And it turns out, because we've created these indexes, if I go about inserting, updating, deleting data over time, I'm actually going to slow down those operations just a little bit. Not by a huge amount, but presumably the database has got to keep this tree balanced, as we've discussed in the past too, so that if we insert or update or delete things, we make sure that the tree itself is still efficiently stored in memory. So even though we might get massive savings with our select queries, we might increase the time required for some of our other operations. But odds are, if you are a very read-heavy site or application, like IMDb itself probably is, where many more people are using the data than are changing the data, odds are that's going to be a net positive. All right. Cool. With that said, enough about design. Let's focus lastly on how we might use these databases and some of the problems we might run into. Now, it turns out it's actually very common in the real world to use multiple programming languages together. Thus far today, I've been focusing really just on SQL in isolation and on Python in isolation. But sometimes it turns out it would be very compelling to write a Python program that maybe takes user input, but still harnesses the power and the capabilities of SQL by using SQL inside of Python. And so we can actually do this by using CS50's own library, which in addition to getInts and other such functions that we implemented for you in both C and Python, in the Python library, we also have support for SQL databases. And these aren't so much training wheels as they are just very user-friendly features on top of proper SQL databases. That is to say, it turns out that when you use a third-party library to query a SQL database, there's lots of functions that you might have to pick up in this language or that. In CS50's library, we do simplify it a little bit, but without hiding any of the underlying functionality from you. And so in fact, at this URL here, if curious, you can see the documentation ultimately for CS50's own library. But within this library, do we have functionality like that allowing us to execute SQL inside of Python? So let's do that. Let's go back to VS Code and open up favorites.py, but start from scratch here. And instead of importing the CSV package, let me go ahead and import something from CS50's own library as follows. From CS50, import SQL in all caps. This is going to give me access to SQL-specific functionality in CS50's own library. Let me then create a variable called db for short, but I could call it anything I want. Set that equal to the return value of that SQL function from CS50's library, and then specify what SQLite file I want to open. The syntax for this is a little weird, but inside of quotes, what I do is pass in a string here that's as follows: SQLite : favorites.db. So it kind of looks like a URL, but there's a third slash in there. It follows a similar format overall, though. That will take care of now opening that .db file in Python code instead of having to manually run SQLite 3 as I have in the past. Now let's go ahead and ask the human for their favorite language, for instance, by creating a variable called favorite, set it equal to the return value of the input function in Python, which is like getString, and just prompts the user for their favorite. Let me now call db.execute, which is a function or method that's inside now of that database variable because of how the CS50 library opened that file, and execute a line of SQL from within my own Python code. In particular, let me select how many people like a particular language based on the CSV, which is now in our .db file. Select count star as n from favorites where language equals question mark close quote. And in this case here, not to throw too many wildcard characters at us today, but in the context of CS50's library and in the context of a lot of SQL libraries in the real world, a single question mark without any quotes around it is also meant to be a placeholder for a value like the string that the human typed in. We don't want to use f strings. We don't want to use the curly braces in this case for reasons we'll come back to. But the question mark is a placeholder that, much like %s in printf from C, will get plugged in with the actual favorite that the human typed in. All right. Now, I want to do something with the return value of this function. And turns out, when you use a select statement inside of this execute function, what you're going to get back is a list of 0 or more rows. So if you match a row, you get back a list of 1 row. If you match 2 rows, you get back a Python list of 2 rows. If you match nothing, you get back a list with nothing in it, of length 0 in that case. Now, if I only really care about one answer, like the first row that comes back, well, let's do exactly that. Row equals rows bracket 0. So I'm just, for the sake of discussion now, assuming that I'm going to get back at least one, and frankly, just 1 row. So let's just grab it with row equals rows bracket 0, because rows is a list, but row is now a single row. And now, what this function dbExecute does, per its own documentation, is it returns to you, yes, a list of rows, but much like the dict reader in the context of CSV files, each of the elements in that list of rows is itself going to be a dictionary. And the keys for each of those dictionaries is going to be the name of the columns from the SQL table, just like the dict reader is grabbing the column names from the CSV itself. So lastly, let's go ahead and print out the popularity of that there language. Print row, quote unquote, n, because I want to index into that one dictionary and get back the value of n, which, to be clear, was the alias that I gave to count star. Just so I don't have to keep typing count star, I can more simply and more succinctly call it n for number. Let me go ahead and open up my terminal window again, run python of favorites.py, enter, and my favorites say, I'm gonna buck the trend here, and I'm gonna say that C was my favorite, enter. What is this crazy error message that I just induced deliberately for the sake of discussion? So in this case here, it's underlining my entire query here under db.execute. And then I'm being told more specifically that there's more placeholders than values. So maybe a teachable moment indeed. I spent all that time talking about the placeholder value earlier. But what I failed to point out is how you place a value there. So it turns out that the dbExecute method takes minimally one argument, the query you want to execute, but ideally one or more additional arguments for the values you want to plug into those placeholders. So what language am I searching for? Well, whatever value is in my favorite variable, which contains the string that the human just typed in a moment ago. So if I now open up my terminal window and pretend that never happened by clearing my screen, let me now run python of favorites.py again, really crossing my fingers. That was the problem. Didn't do that last time. Enter. I'm asked for my favorite. I'll type in C again. Enter. And there is, thankfully, that 59. So granted, it's still a decent number of lines of code, but notice what's not in here. There's no more loop, there's no more dictionary reader, there's no more conditionals. I have used SQL instead to just declare what question I want an answer to, and I get it back in the form of some Python variables, rows being a list and containing one or more dictionaries in this case. So hopefully that sort of demonstrates how we might combine these two languages. And indeed, in the problem sets to come, we're going to do quite a bit of this. But in our final moments together, feels worth dwelling on some of the bad things that can happen in the world of SQL, much like we saw bad things in the world of C and really any programming language as well. So it turns out that in the world of SQL, and really programming in general, you can be vulnerable to something called race conditions. And the story that was once told to me was this. If you're in college, for instance, and have one roommate, and between the two of you, you've got one of those little refrigerators in your dormitory, and both of you really like something like milk. And so you're determined to make sure you always have milk in the fridge. Well, how might you go about solving this problem if one day you come home and you realize you're out of milk? You open the refrigerator, you see nothing in there, you close the refrigerator, and then you go off to the store, ideally picking up a gallon of this here milk. All right, well, meanwhile, suppose in the story that your roommate comes home, opens the fridge, similarly loves milk and realizes, oh, we're out of milk, and so closes the fridge, goes out, and tries shopping for another jug of milk. Well, what happens, unfortunately, if both of you have inspected the state of your refrigerator and made a decision based on the value therein, well, at some point, both of you are going to get home. You're going to end up with 2 jugs of milk, which is way too much milk because you don't really like milk that much, but that, therefore, is a problem. So how could we have solved this here problem? Questionable whether these props were compelling for this example in retrospect, but more for us later. The problem at hand was that both of you in the story made a decision based on the value of some variable, but you didn't signal to the other person that you're in the process of updating the value of that variable. Better would have been in this story for the first of you to lock the refrigerator physically, or at least put a note on the refrigerator saying something like "gone for milk," to prevent the variable from being updated in duplicate, if you will, at the same moment of time. Now, as silly and as contrived as that story is, it turns out it's representative of something that can happen quite a bit in the real world. Consider any popular social media application nowadays, or particularly popular posts. This photo here is, as of this morning, still the most popular post ever on Instagram based on the number of likes that it got, upwards of millions. But this is actually a hard problem for a company like Meta and any of these social media platforms to keep track of, because presumably when something goes viral online and lots of people are clicking like, there's a lot of potential changes to a database somewhere all at once, because so many people are trying to like that post at a time. And just for the sake of discussion, let me hypothesize that Meta, the company behind Instagram, maybe is using, heck, CS50's library for this, but more specifically using Python and SQL together, but it's really the SQL that's germane for our discussion here. Let me step out of the way here and note that in these lines of code, I'm supposing that first, a company like Meta is executing a SQL statement like this: select the number of likes from the posts table, where the ID of the post is question mark, where question mark represents whatever the unique identifier is for this here post. So that's how Facebook, or that's how Meta is trying to figure out how many likes does the post currently get. Why are they trying to do that? Well, if we go back to the code here, they're then getting from the first row they get back, from the likes column, the current number of likes for that post. Why? Because the goal is to increment it simply by 1. So the third and final line of code here says, update the posts table, set the likes value to this placeholder, where the ID equals this placeholder. And as before, I have not, unlike before, I have not 1 but 2 placeholders here, plugging in likes plus 1, so the value of the variable that we just inspected, and then the ID of the post. So where is the problem here? Well, a company like Meta and any of these social media platforms has so many servers, so many users, probably so many databases, that odds are these inputs are going to be coming in at once. And much like our refrigerator example, odds are, unless Meta is smart about this, they might potentially figure out on line 1 what the current number of likes is. On line 3, actually update that to be the number plus 1. But what if some other user's like came into the database while these 3 lines of code were executing? You can imagine if things are happening so quickly, maybe the first line of code gets executed for me, and then the first line of code gets executed for you, and the queries in the system essentially get interwoven somehow, such that now, even though 2 people might have clicked on like, they might have happened so quickly together that just as the first one is in the process of updating current number plus 1, the other one is in the process of updating current number plus 1, when really the math should have been current number plus 2. And they both end up writing the same value instead of one that is ultimately 2 likes higher than it once was. In other words, if you have code being executed that can somehow get interrupted by other code being executed on another server, maybe with the same database, something called a race condition can happen, much like both of us inspecting the state of the milk in the refrigerator while someone else was in the process of updating it as well. So it turns out, with a wave of the hand, there are features and solutions in the world of SQL to prevent this, and they are called transactions. A transaction allows you to say to the database, execute all of these queries or none of them. But it has to be all or nothing. It is not acceptable for part of them to get executed, but not the others. You can effectively, therefore, lock someone out of the database, though it's a little fancier than that. But it's similar in spirit to putting a lock on the fridge or a note on the fridge to signal, do not make any changes to this database until my queries are entirely done, rather than only partially done. So here then in green is the right way to do something like this for at least meta. You first begin a transaction. Then you do whatever database logic you want, ideally not much because you want to keep it quick and simple. But then at the end of your code, you commit all of those changes. So this is sort of like making change, but only saving the results to the database at the very end. So it's either saved or it's not saved. So you don't get interrupted partway through. Now, besides these race conditions, there's another problem in the world of databases that can strike you as well, known as SQL injection attacks. And this is actually germane to what people have been calling prompt injection attacks nowadays in the world of AI, where people are trying to trick AI into misbehaving in certain ways by injecting inputs into them that they weren't expected. Same idea with SQL injection attacks. And in fact, these came long before prompt injection attacks historically. With a SQL injection attack, imagine taking user input via anything, via something like favorites.py, or maybe something web-based. So for instance, when Yale students log in to their website, they log in here using their net ID and password. When Harvard students do the same, they log in using something called Harvard key. In both cases, there are form fields in the application or website prompting for user input. But here's the catch. What Harvard in this case is expecting me and anyone to do is log in with their email address and their password. But what if I maliciously and very cleverly use some funky characters or punctuation in my email address that are not valid email characters, but they are valid SQL characters. And we haven't talked much about these, but single quotes are certainly valid syntax in SQL. We've seen those. It turns out that dash dash, 2 hyphens, are also popular as well. But unlike Python and unlike C, which use other symbols, dash dash in SQL denotes the start of a comment. So in SQL, if you do dash dash anything, the anything will be ignored thereafter. So notice what I've done here is I've written my email address, mailin@harvard.edu, single quote, dash dash. Now let's see why this is germane. So here, let me hypothesize, I'll take myself out of the picture, is how Harvard might be implementing login to this database. They have a query in their Python code that says select star from users, where username equals this placeholder and password equals this other placeholder. And for the sake of discussion, assume that username and password somehow in Python came from those 2 text boxes, the username and the password field. Okay. And then what Harvard does is check if I get any number of rows back, that means that I found a row with that username and that password. Therefore, let's proceed to log the user into the website or application. All right, all fairly reasonable, but what could go wrong? Well, here is in green the query we want to execute, but let's plug in those potential values from my own form. If I were to type in mailin@harvard.edu, single quote, dash dash, notice what happens here. And if I'm using not the placeholders, but literally format strings, F strings in Python. So the point here will be use the placeholders, use the question marks, because what far too many people in the real world do is they don't use a library like CS50s. They don't use something that solves this here problem. Here is an F string or format string in Python that formats the same string. Select star from users where username equals quote unquote something and password equals quote unquote something. This is why we don't use format strings for SQL, because this demonstrates a SQL injection attack. Notice that whoever wrote this code, at Harvard presumably, put single quotes around the username placeholder and single quotes around the password placeholder. But what if I, a malicious student, use a single quote or an apostrophe in my own email address, what happens here? Well, let's plug in mailin@harvard.edu single quote dash dash. Now, it's a little subtle, but notice the fact that I added a single quote at the end of mailin@harvard.edu kind of closes the first quote that the Harvard programmer wrote. And then I typed in dash dash. But recall that dash dash means ignore everything to the right. So it doesn't matter that there's another quote. It doesn't matter that there's an and. It doesn't matter that there's a mention of a password. I have essentially tricked the database into treating the dash dash and everything after it as an ignorable comment. So logically, what happens really, and I'm going to gray out everything after the dash dash, the database is only being asked to select star from users where the username equals mailin@harvard.edu. Everything else is ignored. The same conditional comes thereafter. If I get back any rows, log this user in. And so the implication here is effectively that if you were to log into Harvard's system as mailin@harvard.edu single quote dash dash, you could presumably log in as me without even knowing my password, because you've essentially tricked the database into ignoring everything after that username. So this is a SQL injection attack in the sense that you, the user, have injected code, SQL code, into my application by just typing in user input. And so the takeaway here is that trusting user input, bad. Like, you should never trust user's input because it could be mistyped or misspelled at best, but it could be malicious input at worst. You should always assume the worst, unfortunately, of your here users and somehow defend against this. So what is the solution? The right solution here, notice, and it's very subtle, would be to escape the single quote that I typed in. And we saw this earlier when I had to escape the apostrophe and hello, comma, it's me. I could, in code, make sure that no matter what the human types in, I change any single quotes to 2 single quotes to escape them accordingly. But that's going to be annoying and hard to remember all the time. So really, the right solution is to do indeed what I started out preaching, which is use placeholders, like question marks, which comes with CS50's library. But again, this is not a CS50 thing. It is representative of how many, if not most, SQL libraries out there let you execute SQL code inside of another language like Python. Now, a little more playfully, this is a sort of meme that's gone around on the internet here. Here's someone's car with a crazy long license plate, but with a mention of drop database table, which, as you might imagine, drop being one of the keywords we mentioned earlier, is sort of how you go about not just deleting data, but dropping all of the data in a table. And if we zoom in here, presumably what some hacker here is trying to do is trick some of those cameras that are on streets in various countries that try to read your license plate. And if someone wrote code to read license plates that trusts the user input and doesn't just allow for dash dash, but allows for drop database table, you can do really bad damage to databases by tricking them into to executing delete or drop or any number of other commands as well. And in fact, the final note that we thought we'd end on is this here, which sort of inaugurates you, welcomes you into the world of educated computer citizens by name of someone called Little Bobby Tables. Let me take myself away for just a moment and let everyone read here this XKCD. But henceforth, after today, if you mention Little Bobby Tables to most any programmer in the world with a bit of a smile, they should know who and what you are talking about. An allusion indeed to SQL injection attacks. So with all of this power, indeed, as always, comes great responsibility. That then was SQL, and we'll see you next time.
All right. Woo-hoo. Round of applause, everybody. That is it for week 7 lecture on SQL. That was a dense lecture. Lots and lots of stuff to go over and review in my off time here regarding just SQL syntax and trying to understand, the actual language itself. But it's pretty straightforward. Forward. The only thing I can think I will maybe struggle with, like right off the bat, obviously remembering and understanding all those keywords, but also I think something that will be difficult is that whole nesting of queries. So understanding that we're receiving back returns for various IDs, and then we need to cross-reference those IDs to other queries as well. So that'll be something that we have to keep in mind. But we have a lot of notes here, almost 100 lines of notes. I need to go back through and add in a couple more definitions for some more beefy definitions for these guys transactions and indexes and some of these data types as well that he kind of just brushed over and didn't really go into too much depth over. I need to go back through and get those. But awesome, awesome, awesome. Sweet. Cool. All right. All right, let me go ahead and stop the recording then for the lecture. How did everybody like that one? Everybody enjoy that one? Tim says best lecture of the year. Why do you like that one so much, Tim? I like when they bring in like the real world examples, like when they talk about, the cyber attacks, or they talk about, SQL injections or things like that. It really goes to show you like a whole full circle of why you're actually learning this, and so you're trying to prevent against some of these real world, attacks that could happen via, you know, hackers or whatnot, hackers. But it's definitely interesting to think about that there are all these people out there that will try to maliciously impact your programs. So it's something very interesting. So the next lecture is week 8, which is HTML, CSS, and JavaScript. So I know a lot of people have been waiting in for that one for some front end action. Now I do have a little bit of previous experience with HTML and CSS. I did complete half of the Odin project about 4 months ago. So I do need a little bit of a refresher, but I know a little bit just about the HTML boilerplate, how to kind of basically make your way around it with, create. It's kind of like a similar to like Markdown, honestly, and but obviously there's still more features we need to understand about. Obviously, actually understanding how networks work when interacting with computers and servers and all that kind of stuff. That's a whole nother realm that we got to dive into sometime soon as well. But anyways, you guys, I'm going to go ahead and end this stream here for at least for this one. I'm going to take a little bit of a break, probably like half hour or so, and then maybe come back for some live coding. But I wanted to just finish this lecture up for today, and then wrap it up officially and the stream, so I can mark it as like an official, okay, this was for the lecture, wrap ups when I make my notes. So we'll come back probably, look out for an announcement in about a half hour to an hour or so, if we come back for just maybe another hour and a half to 2 hours of just live coding, working on the small business manager project, or even working, maybe doing a leak code or neat code problem. But I'm going to go ahead and take a little bit of a break here, grab some dinner, and continue on with it later. Yeah, because it is Friday. We can go a little bit later tonight if we want to. So I want to just kind of finish this stream to wrap up the actual lecture portion, and then we'll come back with some Python practice in us after that. But anyways, I'll see you guys back in a little bit. I'll let you guys know in the Discord when I come back, so look for the announcement. But I'll see you guys in just a second. Peace out. Bye, guys.